back to another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's episode, we're continuing along in our series within VMware. That's right, we're coming back at you with more of that VMware Certified Professional version 6, and we've been looking at managing availability. We're coming back at you with a part 2 in clustering and high availability. Joining me in the studios is Don Pezet. Don, how you doing, sir?
I'm doing great, Wes. Ready to dive right back in and finish talking about clustering and high availability. If you watched our last episode, then you know what we covered there was setting up a cluster, and it really wasn't that hard to get a couple of machines grouped together and put into a cluster. The only thing is we stopped right there, right? We created the cluster and we stopped. And the way a cluster works by default is probably not the way that you think it does. It's actually not very useful the way that it is right now. So the cluster that we put in the last episode, what it allowed us to do is to have multiple servers, multiple hosts that could see the same storage and not cause data corruption, right? That's what we achieved with that cluster. But if one host were to fail right now and there were virtual machines running on it, they wouldn't jump over to another host. They would just go down. They would fail. I actually don't have high availability right now. I don't even have vMotion, right? vMotion, where I could take a VM and move it from one host to another without powering it down, I don't have that right now in a default cluster. Truly, the basic default cluster that we created is simply doing storage protection. Now we need to get in and actually enable the rest of the features to make it do all the fun and awesome stuff that is what we think of when we think of a cluster, right? We think of all these powerful things that a cluster can do, and it'll do it if we just go and hit a few more check marks, right? Now, you might ask yourself, why not turn these bells and whistles on? If that's the amazing stuff about a cluster, why isn't it on by default? And the short answer is there's actually a little bit of prep work that needs to be done to get ready for it. In an ideal world, we need to have network infrastructure and disk structure and all these other different things pieced together to support the cluster. And we created a shared data store. Remember, we added the iSCSI drives in, so I had that network attached SAN to be able to bring that up and have shared storage between the cluster nodes. But another thing that we're going to need is if we want to do something like vMotion or whatever, is that we may need dedicated network interfaces to support it. We have things like vMotion, heartbeating, virtual SAN, all of those technologies, they use VM kernel adapters, and we have to have the adapters set up to do it, and those adapters aren't set that way by default because VMware assumes that you've got one network adapter you use for management and that you'll have other network adapters that you use for vMotion and heartbeating and all that other good stuff. So you got to go and pick those and set them up, and that's why the advanced features aren't working. So what we're going to do in this episode is run through those advanced features and actually get HA running the way that it's supposed to, so we get the cluster, the cluster of our dreams, right? You know, what it is that we hope to achieve with this thing, right? The first thing is we know that we need HA turned on. If HA isn't even turned on, none of this stuff is going to work. So if I go into my vCenter screen, and I'm going to go down here to hosts and clusters, and I'm going to find my cluster that I made, right? So we made this cluster, IT Pro TV Lab. It's got a couple of hosts in it, host 1 and host 2. They're parked right there. And if I go into the cluster and go to Manage and Settings, we'll see vSphere HA right here. We saw this in the last episode. And the big glaring omission right at the top is simply that vSphere HA is turned off. And it doesn't work so well when it's turned off. We're going to turn it on. Right? So I'm just going to hit Edit on that. And when we go to edit it, I've only got one option. Everything else is grayed out until I turn it on. Okay. Once I turn it on, now we can start to get some of the advanced functionality, even if I were to stop right here. But there are still other things that I want to do. Let's run through some of the things here that it's offering for me. First off, host monitoring. You want host monitoring. Host monitoring is where the cluster, or really vCenter, will monitor each host to ensure they're up and they're working. If a host were to fail, or if a host were to go into maintenance mode, the cluster needs to know about it so that we can shift virtual machines off of it, or at least warn us about it so that we know what to do. So that's a key component right there. We need to monitor the hosts. And the way the hosts get monitored is through what's called a heartbeat. And see how it says right here, the ESX, ESXi host in this cluster exchange network heartbeats. They talk to each other. A heartbeat is a really simple thing. There's actually two different types of heartbeats in ESX. There's the network one they're talking about here, and there's a data store one that's actually a little more reliable. With the network one, we just send a little message across the network. It's actually a very small message, and it sends it very, very frequently. I can't remember the actual interval. I think it's every 2 seconds, but it's really, really frequently. It sends a message that says, hey, I'm online. How about you? and the other servers are sending messages saying, hey, we're online. And so they're all letting each other know they're online. If somebody ever stops sending those messages, we know they're not online anymore, right? So it's a heartbeat. It's kind of like in those medical shows and somebody's passed out and they check their pulse, right? Are they still alive? That's what we're doing here. Do I see that pulse on the network? All right. A data store heartbeat works the same way, except instead of using the network, it uses the shared storage. If you're using a network, it's possible your network could become really congested, really heavy traffic, and maybe collisions or something else causes a heartbeat not to make it through. And we might think somebody's gone offline when they're actually online. If we write to our shared storage, everybody sees the shared storage already, it's kind of like a private network set aside just for using heartbeating, except it's storage also. And it can be a little more reliable. We'll see how to turn that on a little bit later. Here it's just talking about networking. The next option is VMCP. All right, this is VM component protection. By default, the cluster monitors the hosts. If a host fails, then we can move some VMs off of it and get them back up on another host. But what if the host is just fine and it's a virtual machine that's having a problem, right? What if a virtual machine locks up? The cluster doesn't detect that by default. The cluster knows the virtual machine is powered up, but it could be a Windows machine sitting at a blue screen, right? It's got a blue screen of death and it's completely locked up. The cluster doesn't know about that. It just sees, hey, it's running, I'm happy with that, and that's it. Or what if it's one of the vSwitches, like a port group on a vSwitch gets misconfigured, and now the virtual machine can't connect to its vSwitch? Well, the host is up, and we might even be communicating on the management network just fine, but this virtual machine has lost a component that's important to it. It's lost network connectivity. How do we know that? Well, by default, you don't. You don't know that. You can't see it. But if we install the VMware tools on the virtual machine, the VMware tools actually send a heartbeat to the host. Now the host is getting a heartbeat from the other cluster members and a heartbeat from the virtual machines. And if the VM stops sending a heartbeat, then we know the virtual machine had a problem. And we can configure that with VMCP. So right here, VM component protection. If I turn this option on, you'll see it's really just got this one option for me, protect against storage connectivity loss. If the virtual machine loses connectivity to its storage for some reason, it will protect us. And as we configure other things, you'll see where it does more than just storage connectivity loss. It does losing network or discommunication, so it can get things like that network connectivity with the vSwitches. All right. After VMCP, and these are all things we can turn on later too. You don't have to turn them all on right now. We can turn them on at a later time. Then we've got virtual machine monitoring. Okay. Now here's that VMware tool heartbeat. This works in addition to the VMCP, right? So it's kind of like basic heartbeat monitoring and advanced heartbeat monitoring. VMCP being the more advanced of the two. With virtual machine monitoring, here's where we get that interaction with the VMware tools. And so I can come in and I can turn that on. Now notice there's two modes. VM monitoring only. We just talk to the host OS, right? If it's Windows or it's Linux, they're running the VMware tools, we talk to them, and that's it. That works out great. But you also have VM and application monitoring. What's that? Well, there's certain applications that can report their health back to VMware. So for example, I might have a Linux box that is up and running MySQL, okay? Well, the Linux box might be up and happy, but MySQL might have locked up. That process is locked. Well, the virtual machine is up, it sees the network, it sees its storage, it's running along, but MySQL is locked. So as far as I'm concerned, my application is down, right? But there's people who have written plugins for MySQL that let it interact with VMware tools, that let it report its health back. And now if MySQL locks up, we can take some kind of action, reboot the VM, whatever it is that we want to do, we can take an action based on that. But VMware does not create any of those plugins themselves. It's up to the third-party vendors. So when you buy software, if you get MySQL or Oracle or whatever other software it is you're running, look and see if that vendor provides a VMware package to support application monitoring. And if they do, now the cluster can be aware of not just the hardware, not just the virtual machine and its configuration, not just the host OS, but all the way through to the application. And we can monitor that health and fail over when needed. Or just restart the server if nothing else. You have those options. All right. I'm going to set mine to VM monitoring only because I'm not running any software, so there's not really a point in doing the application side. And then right after that, we've got a few last little details right here, which are failure conditions and response, admissions control, data store for heart beating, and advanced options. Here's where we get to the really shiny bells and whistles inside of HA. Okay, failure conditions and VM response. Right, what happens if a virtual machine fails? Right, if a virtual machine shows is not working right, what do we do with it? And you'll see the different scenarios play out right here. If it's a host failure, if the host has failed, we're going to restart the virtual machines, right? When we restart a virtual machine in a cluster, it's going to try and go back to the host that it was on. But if the host that it's on is down, it'll just pick another available host, and it'll boot from that one. So this will basically restart the VM on another host. If the original host has failed, we can't salvage what's in RAM. It's already gone. The host has failed. So we just power up the VM somewhere else. So that's that kind of default response there. If the host is isolated, what does that mean? Well, in this case, the host machine is still up, it's still running, and thus the virtual machines are up and running. But it's become isolated from the network. It might still have attachments to the storage side, but not to the network. Now we've got a problem, because technically those virtual machines are still writing to disk. So if I try and bring up another host, if I try and bring up those VMs somewhere else, now I've got two hosts trying to write to the disk at the same time. And so the default here is response disabled. If the host becomes isolated, it doesn't flip the VMs across, all right, because it's trying to avoid that disk corruption. You've got data store with permanent loss versus data store with all paths down. Okay, these are actually very similar. Data store with permanent device loss. That means that none of our hosts can see that storage anymore. It's effectively gone. So what can we do there? Not really much of anything, right? The data store is gone, so the virtual machine just shuts down. But if it's all paths down, that's all paths down for this host. Other hosts might have other paths to get there, so I might be able to move this virtual machine somewhere else. But you'll see even that functionality is disabled because it's going to assume that the data store itself has failed. And then lastly, we've got guest not heart beating. I turned on guest monitoring, and I told it to monitor just the guest OS only, and so it's monitoring it for that heartbeat. And if the heartbeat ever stops, it assumes the machine is locked up, like a Windows blue screen of death or a Linux kernel panic or whatever. And so reset the VM. It'll reboot it and start that one back up. Right? So those are the default responses right there that it's going to provide in the event of a failure. And we can override all of these on the virtual machines themselves. So you can go into the individual VMs and customize and tailor it. These are the defaults that are being set up. And down here at the bottom, we can override it globally. So here we see response for host isolation, which up here was disabled. Data store with permanent loss, data store with all paths down. And we can change those to something other than disabled. So if the host becomes isolated, shut down and restart the VM. Okay. If I shut the VM down, it's going to stop writing to the hard drive. And when we restart the VM, now it's going to boot it somewhere else where it's not isolated. Now it's ready to work. So shutting it down and restarting it, make sure I don't lose data. I get some downtime, however long it takes to shut down and however long it takes to boot up, but at least my data stays safe, right? That's kind of the goal there. You could just say power off and restart the VMs. Now I'm going to lose data because I'm basically cutting the power of that virtual machine and booting it somewhere else, but that might be okay if I'm trying to get it back up as fast as possible. I don't want to wait for it to shut down. If you work with Windows, you guys know what happens, right? I'm in a hurry, I go to shut it down. Oh, installing updates. Installing update 1 of 25. Do not power off or restart this machine. Crap, right? I mean, that's what happens. I'm in a hurry. So we might just say, look, we're not going to wait for that. We'll just power it off. And know that if something really goes wrong, Windows can run check disk and sort itself out, or Linux can run FSCK and check itself out. They can do that, right? It's up to me how I want to handle that. All right, then we've got the data store loss. If we lose connectivity to the data store, same kind of thing. If it's permanent data loss, issue events is kind of the best option, because if you try and power off and restart the VM, we're talking about permanent device loss. We're not going to get that device back until we fix the device. There's not really a whole lot of point in restarting, but you certainly can. You've got the option. If it's all paths down, it's usually better to try and power off and restart the machine, and that way it can go over somewhere else. Notice there's two options here for powering off and restarting the machine: conservative and aggressive. Conservative means let's give it a little bit of time before we restart it, right? Because it's isolated, people shouldn't be reaching out to it, and the storage might come back up, so we kind of give it just a few seconds there to try and quiesce. And then after that's done, we shut it down and move it. or we go aggressive, which means just as soon as that host is isolated, immediately power that VM off and bring it up somewhere else. So if I'm in a hurry, and these are web servers with static data that feed off a database somewhere else, then I may just want to immediately cut it and move it over. All right, so there's other options that are out there too, but these are pretty straightforward. I'll just issue events on that one. All right, then we've got the all paths down recovery after APD timeout. So the all paths down, it's got a delay timer. See the delay timer here of 3 minutes? Well, what happens after that time? We fail over, okay? So what do we do after the failover happens? Do we reset the VMs and try and bring them up? Or do we just leave them be in whatever state they happen to be in? And the default is to leave them alone. We can customize that. And then the sensitivity. How much time do we want to let pass before we decide that a virtual machine is up or down, okay? And so you can come in here and tailor this. The default is that you've got high sensitivity. And if you look at what that sensitivity means, it's basically set here to say the failure interval is 30 seconds, the minimum uptime is 120 seconds. If I don't get a heartbeat for 30 seconds, then I'm going to assume the virtual machine is locked up, okay? And then we need to take an action. And once I start getting a heartbeat again, I don't necessarily trust that machine yet, right? Because it was locked up. So the minimum uptime is 120 seconds. We're going to wait 120 seconds, 2 minutes, before we decide the machine is healthy enough to bring it back in. Because I don't know if you guys have ever seen this in the Windows world, it's not uncommon, that you get some kind of failure, the machine reboots, it reboots, and then fails again and reboots, fails again and reboots, stuck in a loop. So I don't want to assume it's active when it's still just looping for whatever reason. And with failed storage, that's really common because it goes to boot, it's booting its OS off of some local disk, then it goes to access network storage and it craps out and reboots, right? So that's definitely something that happens. You can customize this, like if we go to low, failure interval is 2 minutes. And the minimum uptime is 480 seconds, so it's a much larger window of time, right? And you can go custom and really tweak that. So if you want something that's even higher than the high setting, you could come in here and really crank this down, okay? Just know that the lower you make these numbers, the more heartbeats it sends, and the more false positives you can get. So more heartbeats means more CPU utilization. More false positives means failing over when the machine was actually fine. Maybe the machine just hit 100% CPU for a minute and got a little busy, and if you just waited a few seconds, it would have been fine, but instead you failed it over, right? So we don't want to go too aggressive on this. Unfortunately, I can't give you the perfect numbers to use here because it depends on your virtual machines. It depends on what workload you're putting inside of them. If these are web servers, you really don't want to be too aggressive with web servers because they do spike CPU. But if it's a database server, you might want to be aggressive.
Would that be something, Don, that maybe you check a baseline just to figure out, that hey, this machine is a production machine? Just do your research before you peek and tweak these to suit them to your environment.
Yeah, and this is where a lot of vendors have workload simulators because what happens, I see this all the time where people build up a test or dev environment, and how many people are working in the test or dev environment? 1, maybe 5. If you have a QC team, maybe 10. Not a ton of people. When you roll it in production, how many people are in your production environment? Tens of thousands maybe, right? So you don't have a similar workload. So if you're going to be creating this kind of baseline, you need to make sure that you have a workload simulator, something that's generating fake workloads so you can get an idea of what that server normally looks like. And then once you know what it normally looks like, you can base these numbers off of that to get a good estimate. You just want to avoid false positives when you can. Failing over is nice. It's convenient, it's fast, it's easy, right? But failovers aren't flawless. You do lose a little bit of data when you do a failover. Even in one where everything's up and healthy and you synchronize RAM, there's still a couple of packets that get lost when the system switch over. And so in a mission critical application, that's not okay. You want to minimize failovers so that you only fail over when there's an actual disaster or when you manually trigger it. So always try and avoid that. All right, now we get to the fun stuff down here. We've got admission control. All right, what is admission control? Well, when you build a cluster only has so many resources. I built a cluster, mine has 2 nodes in it, right? So I've got ESX host 01 and ESX host 02. They both only have 4 gigs of RAM. So together, they've got 8 gigs of RAM. That's not a lot, right? If I create 5 virtual machines and I give each of those virtual machines 1 gig of RAM, well, in my cluster, I've got 8 gigs of RAM total, so I'm fine, right? Wrong. I'm right in that I can do it, but I'm wrong in that my cluster is no longer healthy. If I have 2 cluster nodes with 4 gigs each, That's my 8 gigs of RAM. What happens if one node fails? If one node fails, I'm going to try and take all the VMs that were on that node and move it over to the node that's still up. Well, it's only got 4 gigs of RAM. My VMs have 5 gigs of RAM. I'm going to exceed what's available.
And now it seems like you would need something that determines the priority of those machines. You know, which machines are just, we've got to have those production machines, and you mentioned the dev environment. Probably don't need that machine to fail over.
Yeah, and certainly there's going to be machines that you don't necessarily care about, and so you can tie those to a particular host or not even put them into the cluster. But if you want true balancing availability, you've got to make sure that your cluster can survive the failure of at least one node, all right? And so when you build a 2-node cluster like mine, you might have some problems. And so you might get some warnings about it, right? I don't have a lot of VMs right now, so mine's pretty happy. But if I start creating more VMs, I'm going to have a problem. So the default is that we have what's called admission control. And admission control will check anytime you create a virtual machine, if you go to put it in a cluster, yes, the cluster might have enough memory for it, but if it can't survive a failure, it's going to throw a warning. It's going to stop you from creating that VM. Right? It's going to stop you from admitting a VM into the cluster. It's going to keep you out because it's just too full. The terminology comes from like nightclubs. So you get in line, you go to the door of the nightclub, and they say, nope, there's too many people inside. We got the fire marshal rules that say only 300 people can be in this club. Well, you're number 301, so you got to wait. That's how the VMs are. It won't let them come into the cluster if there's not available resources. So we may want that, we may not, right? In a lab environment, I'll turn this off a lot of times because I'm going to oversubscribe my cluster. It's a lab environment. But in production, you always have to plan for failure. And a lot of people just plan for one host failing. I've got a 2-node cluster. So if I lose 2 nodes, I've got bigger problems, right? So for me, I can only plan for one. But what if I had a 16-node cluster? I have 16 hosts. Well, maybe I want to plan for 2 or 3 of them failing. Right? What if 3 hosts fail? I need the remaining 13 hosts to be able to carry the workload that those 3 failed hosts were carrying, right? Distributed across all of them. So I may need to bump this up and say, I need to reserve capacity for 3 hosts. And now it's going to look at what we've got laid out across there and make sure that it reserves that at all time. And if I try and create more VMs than can be handled, it'll stop me, right? It's a great way to keep yourself honest and ensure that you don't oversubscribe your cluster, right? Down here, notice the slot size policy, right? The slot size. Each virtual machine uses what's called a slot. And a slot is a combination of processor and memory, right? The disk storage is shared, so we don't have to worry about disk storage. You either have the space or you don't. That's not a big deal. But memory and CPU, those are the two that it's really paying attention to. And so slots are kind of a combination. See how it's this maximum CPU/memory reservation. It's both. And when you create a VM, it might be a very small VM that only has so much memory and CPU power. It might be a very big VM that has tons of CPUs and tons of RAM. They're not equal, are they? So it's very difficult for the cluster to evaluate all of this as like apples to apples, right? Because different virtual machines are different. So what we can do is we can leave it where it just looks at whatever VMs are powered on. If the VMs are powered on, it knows how much memory and how much CPU they're using. And so it can use that to balance it out, and that's the default. Or I can create a statistical average. I can define what a slot is. And I can say that a slot in my environment is 1 gigahertz for CPU and 1 gig of RAM or 4 gigs of RAM or whatever. And I can start to define that. And what's going to happen is if I have a virtual machine that needs more than 1 gigahertz of CPU or more than 1 gig of RAM, well, that's a slot. And so that virtual machine may consume more than one slot. And so we can hit VMs requiring multiple slots and calculate, and it's going to look and find that out. All of my VMs fit in that, so no VMs take more than one slot. And now it can evaluate that out based on how many slots we support. If one VM is oversized, then it'll just consume more than one slot. It uses that to balance it out, right? But to be honest with you guys, just covering all the powered on virtual machines works. If there's a virtual machine that's powered off, I'm not really worried about covering its capacity because it was turned off. If I'm in a critical failure, I don't need to go turning on machines that were off. I need to worry about the machines that were on, and so that's what kind of the default that we go with. If you do the fixed slot size, it'll evaluate machines that are off also. All right, then we've got, what I was doing here was define failover capacity by static number of hosts, right? And that's the default, that's the way that it kind of works. But you have other options down here, like way down at the bottom, do not reserve failover capacity. That means, hey, vSphere, don't worry about it. I got it covered. I'll make sure it's okay. I promise. And so when I do a lab, that's usually what I choose, because I may have more VMs than what my cluster can successfully handle, and I don't want to stare at a warning signal the whole time I work with the cluster. So I just disable it, right? So you can turn that off. But the other two options are a little more useful. For example, we can say define failover capacity by reserving a percentage of the cluster resource. I might say set aside 25% of my resources. And if I have 4 nodes, that would be like saying I've got one entire node that I can support a failure of. But if I have 10 nodes, it's going to set aside 2.5. If I have 20, it's going to set aside 5, right? 5 nodes to be able to handle that workload. It's based on a percentage. This allows me to scale, and it grows the amount that it's reserving as we scale. And then there's this one, use dedicated failover hosts. I'm not a big fan of this, but there's a lot of people who are. And what they do is they say, look, we've got a 16-node cluster. I'm going to pick these 3 nodes over here, and I'm going to use them as dedicated failover hosts. I'm going to add them to this list. You just hit the little plus sign and add the hosts, and no VMs will be allowed to go on those. They'll just sit there idle. All right? They'll sit there idle, and in a failure, VMs will get moved over to it. Otherwise, they're reserved.
Okay, Don, now I got to play devil's advocate on this one. Now you're using a dedicated failover host. What happens if the dedicated failover host fails?
Nothing.
Nothing.
Nothing. Absolutely nothing. It's a dedicated failover host. It's got no VMs. So if it fails, who cares? There was nothing to fail over. Now, our cluster will show as degraded. Our cluster will show as having a failed node, but it doesn't have to move anybody off of it, right? If somebody else were to fail, though, the VMs would come over here. Now, why don't I like this? I don't like it because it doesn't plan for spikes. I might have spikes in CPU utilization or something. Spikes in disk I/O is where you normally see it, or network bandwidth. Well, these machines are effectively taken out of the game. If I had left them in, if we had gone with the default up here of planning for our capacity based on static number of hosts, if I had 16 nodes, even though I've got 3 planned for failover, all 16 nodes would be working. I'd be using the network bandwidth or disk I/O, the fiber HBAs on all 16 hosts. I'm getting some money's worth out of all of my hardware. Down here, when I cut myself down to failover hosts, and I have, let's say, 3 failover hosts, those 3 failover hosts are literally doing nothing. And my other 13 hosts, they're carrying workload. And so now I'm getting extra contention on my fiber HBAs or contention on my network adapters that I wouldn't normally have, right? So they're getting a lot busier because of their, just being tied to those machines. So that's why I don't like this one. But if you want to have those nodes set aside where you know exactly which ones are your failover, this is certainly a way to do that.
Now, Don, with the fixed size failover that you're showing us up at the top there, is there any kind of ratio? Is there a best practice that VMware says to follow, or maybe a best practice that you've used? Or is this really just knowing what your environment is and really just kind of modeling it after what you need specifically?
What it boils down to is your tolerance of downtime. So, how many machines do you think could fail at once? For years, people were happy with RAID 5. A RAID 5 array would allow you to have one drive fail and you'd still be on, but you'd be slower while it rebuilt, right? Well, now people are realizing that data is so big that the rebuild time on RAID 5 is too long. It's now everybody hates RAID 5 because they need things to be faster. So they build systems that can support 2 drives failing, or they do RAID 10 instead. It's the same thing with your VMware clusters. If you have a node fail, is your performance going to be degraded? A little bit. You have some extra contention. Is that okay? If it's not okay, then you need to increase the amount of reserved resources so that you don't have that contention. If it is okay, you can save money and you can have that contention. It's no big deal. Do you plan on having more than one node fail at the same time? It's certainly possible, right? Is that okay? If you were to have a failure, are there some VMs that you could shut off to make room? If they're all mission critical, you don't have that room. You need those extra machines. So it's really up to your requirements. And I tell this funny story where every company I've worked for, I always find that their backup system is a mess or non-existent, and that they haven't planned for recovery. And so it's one of the first things that I address, and I'll go to the CIO and I'll say, okay, we need to have a better plan for recovery. So what's our acceptable downtime? How much time can we be down in a given year? And they always have the same answer. The answer is, well, we don't want any downtime. And I say, okay, I can do that. We can have no downtime. I'm going to need a few $1 million. And depending on the size of the organization, it's going to be some money. And the CIO goes, oh, well, actually, it would be okay if we were down a little bit. And you start to establish what is that acceptable downtime. And now you build your solution around that. And every company has a different level of acceptable downtime. If you're a hospital, and this is the system that's controlling all the medicines going out to the patients, you can't accept a lot of downtime. You've got to keep that system up. But if this is a public school and you're keeping track of the students' grades, could that go down for 2 or 3 days? It certainly could. And it wouldn't derail the entire environment. Kids' education wouldn't spiral into the ground. It's just a couple of days, right? So different people have different tolerances, and that's what this really boils down to. All right, I do need to talk about one more thing, which I know I'm running a little short on time. We talked a little bit about heart beating, and I mentioned the VMware kernel adapters and vMotion. Shoot, I guess I have a lot of things I still need to talk about as I think about it here. We talked a little bit about heart beating. We haven't seen it. We talked a little bit about the VM kernel adapters, which we haven't touched at all. And we still have to talk about the quorums, right? The votes that happen between the machines. Darn it, Wes, I think we're going to do a part 3 on this one because I don't think I can get that in the 2 minutes I have left on my timer over here.
Well, Don, that sounds good. How about we'll do that? We'll come back with a part 3. We'll make this another trilogy. Trilogies are great, you know, except certain trilogies we won't mention. But seeing that we are coming to the end of another episode, you got any additional information, or you want to leave it for part 3?
Let's leave it part 3. I need to click OK on this screen, and it's going to turn on all of this HA stuff. We're not really going to see anything different behavior-wise right now. It's when you have a failure that you'll see the difference, and we do need to configure those adapters. So even if I hit OK right now, it's probably not going to quite work. There's still a little bit more we need to configure, so definitely check out part 3.
All right, well, we appreciate you being here with us, Don, and we appreciate you, the viewer. Come back and see us for part 3. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.